Okay, so this is the second video for chapter 3. So basically all of chapter 3 is about graphing stuff. Well, I own a graphing calculator, so really I don't need any of these things. But it's giving us an idea of how people would have graphed this back in the day. And I already said, well, maybe you got some arrows somewhere. Maybe someone put some arrows on there for you. And then there would be some dots on the x-axis. And those dots would be like the zeros, the places where it crosses the x-axis. Okay, zeros or x-intercepts, the same thing. And if I know it's got to go through that point right there, well, I don't know. Does it go straight on through and come up here, or does it turn around and go back that way? So this would be, it just sort of touches. And here, maybe that one actually just goes up through there. So that would cross and cross and cross. Okay, something like that. Well, that counts as the graph. Even though I didn't put any kind of scale on the y-axis, who knows, it might really go something like that. I can't really tell whether it spikes way up high or makes nice gentle little curves based on knowing where it crosses and touches and knowing the arrows. I can't really tell. My calculator would give me a better idea of that. But we're going to count it as the graph if I can at least make all of the zeros in the correct place with going in the correct direction when it goes through them and getting the arrows to stick onto the ends. That counts as the correct graph. So you only need two things. You need the arrows, which we've already done, and you need the zeros. Okay, each of the zeros comes from a factor. So if my entire function was just x minus 5 squared, it's already nicely factored for me. And if x minus 5 equals 0, x equals 5. So the 0 here is 5. And then I'm supposed to say the multiplicity. The multiplicity is the same as that power right there. 2, 4, 5, whatever that power is, that's the multiplicity. So this is multiplicity 2. And crosses or touches, okay, so it crosses for odd powers. For odd multiplicities. And it touches for even ones. Okay, so the 0 is at x equals 5. Let me put the comma in there. The multiplicity is 2. And this is an even power. It's a 2. So it touches. All right, here the 0 is negative 2. X plus 2 equals 0. X equals negative 2. No, equal sign. 0 is negative 2. The multiplicity is, look at the power, it's 4. It's an even multiplicity again, so it touches. Okay, here the 0 is at positive 1. It's whatever, when I stick it into those parentheses, it'll make the whole thing 0. 5, negative 2, 1. So this would be positive 1, multiplicity 5. And that's an odd one, so that crosses. X plus 3, parentheses, nothing else. That's because whenever it's a 1, you don't need to write it. But you can't see it, it's a 1. So the 0 is at negative 3. And that's multiplicity 1, because it couldn't see it. And that crosses because that's odd. Okay, so here's a more complicated problem. It's got a bunch of different factors. So it's got a bunch of different zeros. It's got, that would be x equals 0. It's got another 0 for at 1. It's got another 0 at negative 2. And it's got another 0 at 9. And the multiplicity on those is, that's multiplicity 4. That one was 5. That one was 3. And that one is 6. And so crosses or touches, that one's even, so that one's touch. That's odd, so that's cross. That's odd, so that's cross. And that's even, so that's touch. So if I had this whole thing written out and I knew the leading coefficient theorem on this, and I had these things. I could draw a quick sketch of what it looks like. So that's what this is, where this is going.